Really happy to be here again and continuing to talk about this really critical issue. Aerospace and both aerospace technology and access to space are critically intertwined with the management of global warming and climate change. So it's my honor to be here today. We have Trevor, Dave, and Megan joining us. I'll let each of you guys give a brief intro, and then we'll start off the conversation.
Hi, can you all hear me? Great. Hey, I'm Trevor McDonald from Planet Labs, or Planet, PBC. I'm a product manager there. I was previously there for 5 years, and then I recently boomeranged back. So I'm back in week 2, so I'm a little rusty, so go easy on me. But yeah, at Planet Labs, we're a public benefit corporation, so nature is on the balance sheet, and we need to be commercially viable for our shareholders. I'm one of them too, so I hope we do well. And we have a constellation of constellations. I think that means satellites. Many of them you've heard of, the mega constellations like Starlink. Planet is unique from others you'll hear about in that we image the whole world every day. And basically those data sets from these constellations are helping us with digital transformation and sustainability. We're involved in a number of programs. I could go on, but involving deforestation, monitoring coral health, agriculture, defense and intelligence. So contributing a lot to the security and sustainability of the world, and doing whatever we can to get nature on the balance sheet. There's a quote that people often throw around, you don't manage what you don't measure. So I think that kind of fills right in the gap of digital, sorry, what's the name of the panel? It's digital twins with remote sensing. So yes, thank you for letting me be here.
So does this work? Yeah, okay. So my name is Dave Nilosek. I'm the SVP of Software and Data Engineering at a startup called EarthOptics. We're a soil mapping and measurement company, so we're not quite as high as the satellites, but we have our own sensor package that we drive around fields, and we measure. Our goal is to efficiently measure nutrients and carbon in soil. We also have a compaction product as well, where we measure the compaction of soil, and we use that for our own climate-smart application of trying to not do no-till, but do smart tillage, so where you can till where you need to till and don't till where you don't need to till. So we are a AI data company, so everything we do is based off of data. We use satellite imagery. We use Planet a lot, and so yeah, there's a lot that we do in the digital twin space. Prior to that, I had worked at a satellite company called HySpec and then another aerial imaging company called EagleView, where I ran their whole imaging R&D department for a bit.
Hi, my name is Megan Spencer. I'm a product manager at BlackSky. We are a satellite company. We have 16 satellites in orbit. We specialize in low latency tasking and high frequency revisits, up to hourly revisits, and the most important in some critical locations. I have a background as an analyst doing geospatial analytics and remote sensing analytics. I worked with satellite imagery and drone imagery to drive analytics products for commercial applications. I've done some data management in the imagery space. And now I specialize in commercial products and analytics products. Yeah.
Thank you. Hello. This mic keeps cutting it. All right. Here we go. All right. I do want to get a little bit more into what exactly remote sensing means and all the different types of sensors that are out there, because we've touched on a number of those pieces from satellite to aerial to ground just in these introductions. But backing up a little bit, I really want to start with a conversation about digital twins. What does a digital twin mean in this sense? And when we're talking about application of this data for the Earth, and how does it vary from more traditional models that we've used in the past?
Oh, Okay. So a digital twin, in I think by definition, is a replication of some model, some system in data. I think the big difference between it and a historical model is the intention and the architecture of a digital twin is usually to be continually updated by data that's coming in, whether that be satellite data or IoT data or ground-based data or whatever, so you can model over time the state of whatever it is that you're looking at, as opposed to like a historical data set like the USGS DEM or something, where it's a snapshot in time. And so there's a lot more that you can do with the digital twin when it comes to making predictions, making decisions, real-time decisions, and accurate and relevant decisions based on data.
Yeah, so a digital twin of the Earth would be as up-to-date as possible, as lifelike of the current state of that location as it could possibly be. And I think digital twins, more so than models, help inform the decisions about the present, because they tell you the current state of the location that you're trying to monitor.
Yeah, I think I would. I love metaphors, so hopefully this one works for you all. I think about. I haven't quite adopted digital twin into my vocabulary, but I think this is what works for me. Is think about it like the smartwatch on my wrist right now. It's digitizing some biological thing that's going on with me, my heart rate, for example. We haven't quite had the access to space or the technology or the money funding the measurement of space in that same way. Space is really unique in that it allows scale and frequency that others don't, and that's not to diminish the value of ground-based sensors or other sensor networks out there. They are extremely complementary and actually required for us to do things and validate, so that if we give him data and he's got a sensor on the ground, then it's actually validating that measurement from space, and therefore his customers, our customers, can have confidence in that. We just blindly trust that, oh, my heart rate is 140. I'm just kidding. But it's very important that these digital measurements we're doing are trusted. So I guess that's my take on that.
As we are here for Earth Summit and talking about Earth Day, I'd like to dive a little further into this and what the specific applications are for digital twins when we talk about climate monitoring, when we talk about how we can help mitigate some of the damage that is done by global warming and real-time disaster management. So if anybody wants to kind of chime in on what those real-world applications are today, and we can talk a little bit as well about what some of the potential is.
I'll start. So to give a use case that's a little bit LA applicable, as extreme climate events become more common, we're going to have more periods of extreme fire seasons followed by extremely wet seasons like we've had this year. And that's going to pose an increased risk of things like landslides, because these severe burn scars, they take away the kind of the bindings of the soils, and when you have intense rains, the soils become waterlogged and they're more likely to slide. So remote sensing provides a great tool to monitor the severity of the burn scars and also the degree of vegetation regrowth. And it would help first responders and community organizers understand where there's high risk of landslides, especially before a major storm, so that they can work on putting plans in place to warn the community and to mitigate any effects of those landslides. That's just one use case. There's a lot.
I can give one that I think is actually pretty relevant to this area here. So not current job, but previous company, actually same founder of this company, was trying to model water usage in LA County. And so we did that by using aerial imagery and data provided to us by the California government, and we updated that over time. And we were actually able to see through that process, identify what was not obvious in the data, that there was a small number of people that were significantly using data or using water, and the government was able to mitigate that. And so those kind of micro use cases are really useful in identifying trends that you wouldn't normally see just looking at the data by itself, and having it updated over time and looking at it and seeing like, hey, this person's using a ton of water for some reason, is very useful for answering relevant, applicable problems.
Yeah, there's a lot. I would encourage you to come up to one of us after and just literally ask any question, and I bet you we could tell you about some specific use case that we've experienced. But I would say that falls into climate mitigation and the climate disaster response. You've heard a couple of those already. Judy from Carbon Mapper talking about monitoring methane. Again, this digital twin with remote sensing allows us to measure, just kind of abstract away all the technology piece. What would you want to measure as frequently as possible? So methane, why do we care about methane? We're going to monitor that to reduce, hopefully, the impact on us. And hopefully, these actors will do corrective action to reduce they call it product loss, right? Which could result in millions of dollars to them. It affects their bottom line, and they may just not know it. So again, you don't manage what you don't measure, and these technologies allow you to see things that you otherwise could not. And I think once you provide that transparency, a lot of people will take the corrective action for their license to operate, and also because they just don't know that it's affecting their balance sheet. For example, I was a small part in monitoring global coral reefs, and monitoring them to identify when bleaching events are occurring around the world, and allowing those countries and other NGOs, nonprofits, to take action. And it's resulted in, I'm forgetting the term right now, but it's basically like blue carbon. There's an investment from a firm to protect this given area in South America, and that's a result of this technology. So literally, there are 1,000 use cases. We'll help you figure it out.
I was gonna say, the one that's really relevant to what we're doing right now at EarthOptics is trying to track soil properties over time and create this database of, at least nationally, the properties and chemical properties and physical properties of soil. But what's related, to a lot of what's been talked about today is, measuring things like carbon sequestration over time and keeping that up to date. Data, that's the hardest thing, especially with carbon, is getting accurate measurements of what's actually going on. And so having some sort of digital twin for that, that is fueled by accurate and quality data is really powerful.
I have too many use cases flowing right now, so I'm just going to say one more. You helped with this one. So mitigation and response. So we want to protect what we've already got, or we want to slow down things. So Planet and these technologies, in partnership with some other sensors, can actually measure trees, so the carbon mass from space. So that's just cool, right? Like, holy crap, like how much is in that tree over there? Or how much is in the Amazon rainforest? Where's the largest amount of this, so that we can prioritize protecting that? And again, that opens up carbon markets. So when you think about carbon markets, like downstream, you could validate, you could monitor, you could do a lot of different things with all of the technologies that are represented in these groups here. So that's just one more.
I mean, it is amazing the data that we are getting from space today, from aerial imaging. About 60% of the data that we use to monitor climate change comes from space, comes from remote sensing today, which is a really important piece of how we continue to grow and manage this. The fact that we can monitor individual trees, that we're at a close to real time function here is really significant. We also, we talk about the earth and we talk about the soil and the trees, but there's also a very human population component of this. The same data and processes was used to monitor human population shifts during the pandemic and to help allocate resources. So there's a lot of potential here that people will feel in their everyday lives as we look at more and more stress on the climate and the fact that there will be specific populations that are more impacted than others. So we've touched a little bit on some of the specific data here that we're using. What is the most challenging as we're trying to build these models that are accurate? What are the largest challenges in accessing the data that we need to build this?
I mean, I'll do the easy one, data quality. Like, data quality is, and depending on the type of data that you're getting, it's hard to build a model. It's hard to build a digital twin if you have to do a tremendous amount of data cleanup, or you at least have to have really good processes for data cleanup so that you're not inserting bad data or errors into your model. And that is probably one of the biggest sources of challenges that comes from building a model like this. In any system or any case.
Yeah. Unfortunately, a lot of the situations where satellite imagery is most needed are also the worst conditions for collecting satellite imagery. So immediately after a hurricane, we often need to wait a day or two to get a good image because there's still lots of clouds. In the event of a fire, smoke will obscure the actual active fire zone. If after an explosion, we might see, again, smoke clouds obscuring the area. So that really limits how quickly we can get imagery after those sorts of disasters. Fortunately, there are so many types of remote sensing imagery that there are other types of images that you can get, like radar data that can see through clouds and still kind of give you a picture of what's going on the ground. But there are limitations to that as well. There are trade-offs in any type of imaging, and in that case, you're probably not going to get the resolution, or you won't get the same type of information that you would in electro-optical imagery.
Yep. Yes and yes. To your point about data quality, I think that's why these are so complementary. If you were a customer, you probably wouldn't just want one data source because they complement and they make the quality better in different ways. I had a former colleague say answers, not archives, which basically means like, cool, all this data is here now. What are we going to do with it? And why does that matter? We're up here talking about a pretty heady subject. Space is really sexy. Satellites are sexy. I think the technology is super cool. But frankly, that doesn't matter unless we can make it understandable to maybe not my grandmother, maybe not my mom, but make it accessible. Google Maps has done a great job at making something really, really technical super easy for us to use. What if you had to understand how GPS works to get from here to wherever you're going? That's not going to happen I don't think I have a map in the back of my car, but that just isn't going to work. So the one I would point out is just from, which I think is our job as product managers, is the easier we can make it to understand and use, the better it's going to be, the more adoption there's going to be, the more impact there's going to be. So that's the one I would go with.
Yeah, building off on that interoperability. So one way to reduce the amount of error that you have in your data is use other data sources to validate, cross-check, whatever. But one of the challenges in that is there are, especially with geospatial data, so many different standards, so many different ways to ingest it and deal with it, and some of them are proprietary. And I saw a cartoon the other day that there was a group of people looking at the 11 standards and saying, oh, we should just make one more standard just to rule them all, and now there's 12 standards. So, right, so it's you know, there's being able to unify on one type of way of communicating with data would greatly increase our ability to be able to, you know, come together and build a more powerful model or digital twin.
Great business ideas for all the entrepreneurs in the audience.
We can use your help. Please help us.
Just put a shout out there for cloud native geospatial stuff.
Yes.
Element 84, it's a good company.
As we look at the difficulties around data, both interoperability and just even availability, as we look at some of the NASA satellites that are getting ready to retire, these models that are being built are really important for us to make long-term plans. You know, they're driving forecasting and large global spends. How do we continue to make these models better? What's, again, like, are there specific technologies that we need to see in the market today that we don't have today?
I don't have a microphone. I don't have an answer, honestly.
Okay. Personally, where I think there's a huge market and also significant room for improvement are 3D models, derived 3D models of the Earth based off of satellite data. That can be done through a process of, it's called stereo pairs. If you take an image of an object from two different locations, you can derive a 3D model off of that. It's an incredibly valuable proposition. I do think there's some work that needs to be done to create 3D models at the level of accuracy that we really need to solve a lot of these complex problems. And I think there's a lot of exciting development going on there. Yeah, I think there's great opportunities there. We'll get there. But yeah.
Yeah, I'm going to agree on the global DEM. Yes, that is, the DEM is it's a really hard problem. Super nerdy problem, but it's, you know, having accurate elevation is just a challenge to get. So yeah, definitely something that would be useful.
So, I mean, I would agree with that too. I think there's various levels of things that need to be solved, and some of them, you know, I agree. I think digital elevation models, which is just, you know, if you go and you look at like a 3D scene, you can actually see the contours of the land. It's actually a really hard problem, which is why we're talking about it, and I think it's what a lot of people think about in our space when they think about a digital twin. I guess my answer would be, I mean, it kind of leans on your answer about interoperability. A lot of the data that we have isn't properly being put to use in creating maximum value, and I think some of that is around humans being not very, maybe we need better human technology. So better business models, making it more accessible, more cost effective, things like that. It's possible today, it's just our industry is evolving. And also to the interoperability part, I think that, you know, again, if you go and you buy a product from one of us, we collectively as a community need to make sure that it's interoperable for you. And if you start to think about that, there's, you know, well, no, that's my customer. We're going to do it this way, and they're going to do it this way. And I think, as an industry, need to continue thinking more about the customer and how they're going to interact with it. So, kind of a cheap answer, but, you know, humans need to do better.
I'm gonna show the fact that I sit in front of a keyboard all day. I think, you know, adopting some open source technologies, things that are shared between businesses, between companies, especially in the geospatial world, will help a lot with that. I mean, I already said the cloud native geospatial push, but everything around that kind of technology, like the spatio-temporal asset catalog and those kind of technologies, which are defined and shared across companies and intended for data sharing and querying and data scientists to do their work. You know, the more companies that support that kind of standard, the easier it will be to do that. So, you know, leaning on open source and and community supported standards, I think will help a lot with that.
As we talk about some of this development process and customers and some of these business opportunities, I'd like to talk a little bit more about some of these specific use cases. We at Starburst focus specifically on advancing the adoption of emerging technology in the market. We do a lot to support entrepreneurship. Who are the customers in these use cases? We talk about this, for example, with insurance. And there are some of these things, insurance specifically, having better data opens up the opportunity to actually get insurance where it may not be available currently today, which is very relevant for those of us here in California. But what are some of the other kind of applicable use cases from a customer perspective?
I could go crazy on this one. Yeah. So traditionally, because of the NASA, ESA, the space agencies of the world, and their investment, it's been traditionally defense and intelligence and natural resource management. So agriculture, water, forestry to some extent. And that's where, if we're looking at a curve of customers, there's small customers with big budgets, and they're also the most advanced. So if we do our job right, we can hit those customers fairly straightforwardly. The fatter part of that curve is industries like you're talking about, like the exciting ones like carbon market. I would love to see the water market being able to use this data, hydrosat, our data, your data. There's tons of opportunities out there. Civil government, I'll try and give you a story here so you can feel it. There's an organization, a trust for a particular state, I cannot name, but they have to monitor a large portion of land frequently for encroachment violations. Now, this doesn't squarely fall into the traditional one, but I think that civil government hasn't quite squeezed, like globally, hasn't quite squeezed the value of managing land and resources and taxpayer money as best as they could with this technology. They used our technology to monitor the land, and it resulted in $2 million in additional fines. So that's not small, that's not super big. I mean, for them as a land trust, it's a really big deal. So that's a good example, but literally maybe we can get someone to ask a question about what industry they care about, and we can try and spin one off. I don't know.
Yeah, I guess to give another LA example that I've been thinking about recently, I think about a year ago, National Geographic published this amazing article about Los Angeles and urban tree canopy, and showed an inverse correlation between the amount of urban tree canopy a neighborhood had and the air temperature. So it's not only a climate issue, it's also a social justice issue. Because wealthier neighborhoods have much more urban tree canopy and poor neighborhoods have much less and are therefore much warmer. And I think that satellite imagery would offer a great solution in, one, tracking the amount of urban tree canopy and also aiding in setting goals and measuring goals in terms of increasing urban tree canopy in lower income neighborhoods. That's one solution. There are other applications regarding things like monitoring what percentage of the city have drought-resistant landscaping and things like that, that I think, municipal governments can really use this data.
I'll give a slightly more generic answer. So, sorry. I think probably all of us at one point in time went on to that. Back when the pandemic was in full swing. I think it was a college student or something, made this one website which just tracked the confirmed COVID cases across the planet, really. And that was mostly real time. That was coming from data sources. That was a form of a digital twin. And I think what that did was that accelerated information transfer. It made it a lot easier for people to understand what was going on in their planet. And so that's really the type of application that you get, is that you get better, faster, more real-time understanding of whatever system that you're looking at, whether that be carbon or disease or climate change or whatnot. The more that you can bring that to light through a digital twin, through being able to visualize it and show it to other people, that's really where the power is and where the customers are too.
And just to see that global effect, I think and that's a really key point. And when we look at satellite data generally, we talk a lot about the overview effect actually from space and the perspective change that it brings when you realize that it is just one planet and how fragile and interconnected everything is. And I think that's a lot of the power behind these digital twin models, is that it allows us to see how many interdependencies there are between all these different factors and how much complexity there is and how delicate the systems really are. And so when I think about this technology in the long run, my hope is that it really does enable us to act in a more global fashion and make more global decisions for global problems. But yeah, taking that kind of further time step back, what excites you guys the most about some of this long-term potential here? Or are there specific technologies that you're really excited to see continue to develop in the next 5-10 years?
I don't know if this is another cheap answer, but I'm going to go for it. Continuing to see, yes, the financial support flow into the particular companies building the satellites, but also Starship. Whether or not you like the guy with the bird app, throw that aside. Starship is going to fundamentally change the game in terms of what we can do as launch. We need launch to get to space, and I think all of the companies operating space are doing their best. So don't worry about space junk. It has to deorbit. Don't worry about anything falling on your head. But I think the continued cheaper access to space and frequency of access to space, as well as we at Planet, we probably aren't the first ones to say it, but we've strapped ourselves to Moore's Law, and that means that the miniaturization of the technology just by itself reduces weight, and we can continue to put more and more satellites up with better technology. So I don't know if that qualifies as an answer, but that was mine.
Coming from the aerospace industry, that was a great answer. I like it.
I'll give you an even cheaper answer. So everything around AI that's been exploding for the past, for a while now, but for some reason it seems to be really accelerating right now. You apply that to something like a comprehensive digital model of a system, then that's exciting and what you could compute very quickly. It's also a little scary too because of there's privacy and security concerns depending on what kind of system that you're looking at. There's obviously remote sensing digital twins. There's healthcare digital twins. There's all kinds of things out there that also include private information that could very quickly get exploited. So that is a little scary, but it's exciting that how fast it accelerates your ability to get answers.
Yeah, I would say probably what excites me most is emerging AI capabilities that can get more information out of imagery. We have every day. There's just constantly more and more satellites in orbit, and we don't even have we don't have imagery analysts to look at a fraction of that data. It's an incredible amount of data, and a lot of it I don't think we're using to its full potential. I really think that AI is going to unlock a lot of new information, a lot of answers out of that data, out of that imagery.
Yeah, so we got this chat GPT thing over here going. This is perfect. Another shameless plug for Planet, our CEO talks about queryable Earth. Like Google has indexed the internet, so all of us can go into that little search bar, and Bard or chat GPT may change the game in a fundamental way, but queryable Earth would be the layperson can go and type into a search bar, show me the most vulnerable populations of coral reef or forests or urban heat island, and you don't have to know anything about where that information is coming from unless you want to. So I think that, mixing those answers together, I think that, talking about making it accessible in that way with the AI models and that thing over there, and the data. We just need to do more and make it more valuable.
There's another tangential technology, parallel technology to AI. Sorry. There we go. It sounds quantum computing sounds kind of sci-fi and whatnot, but significant progress being made in that area, and if that comes to fruition as researchers and computer scientists have anticipated, that drastically changes our compute capabilities, which then increases our ability to do larger AI models, train bigger things, and make bigger models. And so that is a technology that a lot of people are looking out for, including the big, like AWS and whatnot.
All right. Anyone have any final thoughts they want to share before we open up for some questions?
Tell us what you need.
On the subject of quality of data and data that you guys are inputting, what do you think about the idea of backup systems to make sure, to try to ensure the accuracy of what you're entering into whatever database? Are those already exist, or are those needed, or what?
So backup systems in the sense that you're
Well,
storing data.
in other words, what I mean by a backup system would be something where you talked about the making sure that the data is good data and accurate. So the backup system would be able to flag things that are questionable or clearly shouldn't be in there. That's what I'm saying.
Yeah, I think at least in the defense world, there's a lot of that. I think they call that like tipping and queuing, being able to build off of other data sources to validate and whatnot. I think that is certainly something that's going on now, and it's using other data sources to validate your decisions, and the answers that you're getting is certainly something that is being done and is useful.
Yeah, in the satellite imagery world, I guess there's two different places where accuracy could be validated. One is that the accuracy of the image itself. There are a number of algorithms in place that verify the positional accuracy of the image, that check whether or not there are clouds present. So it'll say, are you looking at the Earth or just clouds? That'll look for bad pixels or scan errors in the images and try to flag those or correct for those. The other place where we want to make sure the data is accurate is if we're using that imagery to inform analytics products. Obviously, we want to make those as accurate as possible. And I think in those cases, it's best to bring in other sources of data whenever possible. So if you're using satellite imagery to make a flood map, you might want to bring in as many on-the-ground flood sensors as you can. And they just give you a point, like single point locations that you can use to verify any of the derived products of your images.
So the topic was digital twins, and I want to talk about, or ask a question about digital twins at two different levels. And I think one level is that it seems like a lot of the current state of the art is still, I'm taking these satellite images, which are static snapshots over time. So it's actually geospatial temporal, how we need to think about them. And we talked also about kind of combining data, potentially even at different resolutions, right? I'm combining mount data, I'm having my checkpoints. So my first question is, do you see actually in the analytics platform space to actually fill that gap, right? It seems like customers independently have to go through the exercise of bringing these data sets together. But is there something to be done that creates this unified world, even just all kinds of remote sensing technologies, maybe combined with some local data capture?
Yeah, so I think an example, so NASA and ESA both have a bunch of satellites going, and they individually had their own Landsat, and then they had Sentinel, and they actually fused these data sets together, monitoring different spectra at different times, and they have what we call a fused product. Similarly, us two sitting next to one another, or you two sitting next to one another, we're validating and fusing data. So we very loosely use that, and I think the idea is 1 + 1 = 3. It also goes to the validation question before. So yeah, that's happening today. For a customer, being able to do this themselves, very small population of people, but there are marketplace types where you could go and access all these different data sets in one place if you wanted to do it yourself. Try to.
That's also just a different technology area where people are working today to make these large, complex data sets more easily interoperable, because it's obviously a big challenge, both with different sources of data as well as just the global distribution and human variance in how and what we measure. So I think that we'll see significant advancements in the fluency of data over the next few years.
Yeah,
Second, then goes the level up, which is, and we talked a couple of these use cases earlier, right? Say for tracing carbon through supply chain, it is one thing to capture what is happening, say, in a plantation, around a factory, a plant, and then seeing how that actually moves, say, for example, through containers, across the ocean, elsewhere. And of course, this can all be modeled again with digital twins, right? And we probably have isolated twins for every single of these stages, but it seems still that we are not really able to connect them properly. And also then, say, bringing in AI to fill in, through simulation, the blind spots between the captures we do in the data. And maybe also anything you can share, what you see as important developments, closing those gaps, right? Going from the snapshots, the GIS view, to that global view that often needs to use other data sources as part of the modeling.
Yeah, I think a number of companies have proprietary versions of that, but I think there's a whole community of people that try and build this, they call them like analysis-ready data cubes or something like that, and it's all about that. It's all about bringing together, in a standard way, different data sources and being able to do, effective analysis on it through a common interface. And again, going back to like the spatio-temporal asset catalog is one basic technology that allows you to start merging things together. But then there's at a resolution level, at an actual compute level, that becomes a little more challenging, especially with geospatial misalignments and whatnot. But there is a community out there, and they're largely in the open source community, but trying to do that, and they. I think there's a conference called the Analysis Ready Data Conference or something like that.
It's in May. I'll be there. Yeah.
Is that what is the name of it?
It's analytics, right? It's ARD something. ARD.zone. Go there. You can find out more.
So I attended that last year, and there was so much information about how people are trying to bring data together, just not in a proprietary way, just in an open source, like everyone bringing everything to move everything forward. I would check that out if you're interested.
If I could, a different take is, so that's very important, and I think I'll talk about the business models that are kind of evolving, and then how that relates to like ESG, and I wouldn't trust all your ESG funds. Just take another look at them, because the full supply chain is really difficult to track, but the technologies can help. Now, how that relates to the business models is, our industry is still, kind of a clumsy teenager in a sense, and in other ways really, really sophisticated, but still clumsy teenager in other ways, like building a community and building the interoperability, the platforms to exploit all these data sets together to get to being able to get to like an ESG full supply chain tracking. There are companies out there that have been trying to do this I think when I was talking about needing better humans, the companies are evolving to allow this, to make it more accessible for folks to go and do that, and really, taking that true platform approach where you have the data and you have the tools sitting next to each other, and you're allowing the ecosystem to go and build these use cases, build a business, and contribute overall. So maybe a little different take.
Well, am I okay? So what you just mentioned actually is the perfect segue into the question that I had, because my question is specifically about ESGs and corporations, and just wondering if you had any use cases to share in regards to how businesses have used digital twinning, specifically businesses, corporations who are interested in like sustainability impact from a just, like the Googles, the AWSs of the world, corporations like that. How do you have any examples of use cases?
I've got one, but I don't want to hog the mic. I'll try and be quick with this one. So a large percentage, but not a majority of Planet's business is with agriculture. So the major ag companies we also do a lot of business with or get our data to smallholder farmers as much as we can, but they're a lot more distributed than these major ones. I'm 2 weeks back in, so I'm going to withhold the company's name just so I don't get fired. But this particular company has their own sustainability targets to reduce nitrogen input, to reduce water use. And with all of this combined, with our data, it being validated, maybe some more verification, they have significant results in terms of reducing their nitrogen input, reducing their water use, and contributing to better outcomes, well, for all of us because we get to enjoy some of that food, but for the farmers themselves that are a little bit abused within our ag system, and I think across the world, but I would encourage you, I can direct you to this too. As much public information is out there, I'd be happy to point you to it, but I don't have the metrics on me, but it's significant to their business and sustainability goals.
Yeah, there's a company, I forget the name of the company, but I just stole someone from there. I hired someone away from their company, but it was a company that measured green metrics. So they had sensors in buildings, and I guess it's kind of related to what was talked about earlier with trying to track how the carbon effects of old buildings around here and whatnot. Being able to model a building system after you've made changes and actually see if something is you're making less of a carbon impact at a micro level for a building manager or something. That is a use case I've seen a couple times, and so those kind of smaller use cases exist as well.
There you go. Okay. Yeah. So less of a corporate use case, but governments often use satellite imagery to track sustainability and environmental hazards in their countries. Recently, BlackSky monitored an oil tanker in the Gulf that was disabled and kind of just sitting there and left to degrade and was posing a pretty significant environmental risk. And so the nations around had an interest in making sure that was cleaned up before it caused some disasters. And yeah, I think that's one use case, is just making sure that if you're a business or a country, that none of your assets are causing environmental damage.
Got time for maybe one more question?
While you're in transit, I think there's one more about oceans. Global Fishing Watch is another one you should check out, and they do a lot of great work using anything and everything they can get their hands on to monitor the illicit. I'm forgetting the acronym, IIUC, but Global Fishing Watch is another good one.
Hi. Hello? Oh, sorry, I didn't mean to shout. I think for a lot of us that work in computer vision, the problem isn't like, is there enough data out there? the problem is labels, right? Quality labels. We don't want to hire like small countries worth of mechanical Turkers or whatever to label the data. So you guys are the ones with the, I'm assuming, petabytes of data. Do you guys have kind of like noisy labeling plans in the future to kind of use some of those more cutting edge techniques to generate labels without humans?
I don't have petabytes of data yet.
Yeah.
We are very.
I think we do.
Yet. But, yeah.
Yeah. So I'm 2 weeks back on the job. I'm not quite sure that there's actual plans on the roadmap, but I would imagine that we absolutely need that for our customers when it comes to, there's traditional remote sensing techniques that are more like physics-based, like modeling, and not like hot dog, not hot dog, or car, what type of car. There are both, and we both have systems that need that type, and I would imagine we need that, obviously. There are some cases where I think there's going to be auto labeling, but there's always going to be a human in the loop. Like reducing the dimension of the data coming down to an analyst is still something that you'll see in all of the government press releases between any company you see with remote sensing. It's about reducing where do their eyes need to look? If you're looking at the Ukraine conflict, where do I need to look today? Where do I need to look tomorrow? And that requires this auto labeling. And I think as our industry is getting used to giving access to startups to be able to do this at large, to have access to it. Traditionally, it's been very closed. And I think you'll hear democratization of data, and it's essential to you being able to build that auto labeling system.
Yeah, BlackSky we have done a lot of work in labeling data. We do have huge amounts of data that we have labeled properly. We do sell it as a product, but it's unfortunately not at all geared towards commercial markets or applications. It's not at a price point that's reasonable. And I think there's a big opportunity there to, I guess, use all the information that we have on data labeling and turn that into something that other people can use. And there are a lot of challenges, and I think we'll get there. Right now, what I see is one of the more challenging problems in data labeling is essentially taking a site and labeling the locations of that site, so that you can know what's going on in these locations. Knowing if you're looking at an airport, knowing where is the runway. That sort of labeling tools, and we don't really have a good solution for that. But yeah.
Last question. Here's Gary.
Okay, thank you. A great conference. Thank you all very much. My last question is about the privatization of the information, and whether, one instance was given about a dangerous ship that was sunk, and you got the individual countries to work on it. I wonder, when you consider countries like Brazil that are doing so much damage to the environment, you can't believe it. So in terms of getting the information to the politicians, and the right politicians is crucial. And secondly, also, getting information out of corporations like the fossil fuel industry that knew about the problem back in the late 70s. So the education of the politicians, even in this sophisticated country, the House of Representatives and the Senate are so ill-informed on what is happening right now, let alone what might happen in the future. For example, the methane in the permafrost that released in a feedback loop is extremely dangerous. So that's quite a challenge, isn't it, to get to the politicians that really can do things.
Yes. It all comes down to to how you present it and how convincing you present it. Like that, I mean, that's half of, you know, at least a quarter of what you do in data science is making sure that you can present it in a consumable way that is understandable to you know, policymakers and whatnot, that allow you to actually bring the impact, you know, to what actually is happening to the policymakers. And there's lots of technologies going out there that help you with that type of visualization. So the more we go and start using those technologies, I think the more effective we'll be in transmitting that information and the potential impacts of it.
Yeah, I think this is one of the reasons why it's so important that we have smaller organizations, really dedicated special interest groups that will make noise about these issues. I think we can provide the data, and if we can get into the hands of those people that will make noise and make noise in the right circles, I think that's going to cause some real change. Yeah, and if not, there's always media companies.
I think this comes back to the Google Earth analogy, and a lot of the conversation that we've been having today around the access to data, the reliability of data, the trust that we have in these digital twins, in the forecasting ability therein. This is why we need to continue to focus on advancing development across all of these different areas, because we need this. It is never going to be able to be applied until we get to a point that it is easily accessible. And so that's what we're all working towards.
Yeah, if I could just add to that, I think there was a little bit of like maybe a compliance and regulation piece. Like, we're regulated, so we can't sell to, and we shouldn't sell to bad actors that are on lists for. So just to throw that out, so that's very clear. But the other half of that is, I think, generally transparency. So you'll see a lot of satellite imagery, especially in the last 10 years, in news articles, in press. One that was really prevalent, right? There's actually two. The Evergreen ship that was stuck in the Suez Canal, there's 1 million pictures of that. Now, that's low. I know that really disrupted supply chains, and that's important, but more importantly, the Ukrainian conflict. There was images from all of the sensors in space. When Russia was saying they were doing one thing, they were actually doing the complete opposite. And in past years, you haven't really had unclassified assets like ours that could take images and provide that transparency. So whether it's a Ukrainian conflict or it's deforestation or it's like the coral reefs or you name it. I mean, there's a ton of stuff going on around the world. These images speak truth. I know there's models that can fake it, but that's where the tracking and the systems that we have to make sure that these are for real, we have those systems built into our entire pipeline. So I think it's really about transparency, and we're really lucky to be living now and have organizations like all of ours that provide that information out to the public so that they know.
That's great.
Awesome.
Thank you all.